Hello everyone. In this video, I'll be solving previous year TIFR questions, and this will be basically mathematical fields I'll be solving. Okay, so yeah, first question. The pattern of TIFR, like for mathematical fields, is a bit different. Okay, so please practice according to that. So first question will be limit limit extends to infinity x log x plus 1 divided by x minus 1 is equal to what? Okay. So the options are 2, 0, infinity, 1. These are TIFR 2020 questions. So that we will go to 21, 22, 23, 24. So limit x log x plus 1 by x minus 1 is equal to what? So these are very typical questions, like you won't be able to solve it if you just sit and like try to solve it. There is a different um, way to solve it. Like you have to directly put the formula of this one, and that you have to remember. So actually, this is log x plus 1 divided by x minus 1. It has a formula with it. The formula is 2 whole into 1 plus x 1 by x plus 1 by 3x square. Okay, sorry, 3x cube, my bad, plus 1 by 5x to the power 5, and it will go on like that. So whatever the power is, the coefficient will be the same. So that is the this is the formula log x plus 1 by x minus 1. This is the expansion of log x plus 1 by x minus 1. Okay, yeah. So what to do now? I will just x. I haven't multiplied x here. So if you multiply x, so x log x plus 1 by x minus 1. Okay, so that will be 2x 1 by x plus 1 by 3x cube plus 1 by 5x cube. Okay, so, so I will multiply x everywhere. So, so what will happen? 2 whole into 1 plus 1 by 3x square plus 1 by 5x 4 plus, okay, yeah. So this is a x log x plus 1 divided by x minus 1. Okay, what is the question exactly? Question is limit extends to infinity. Limit extends to infinity x log x plus 1 divided by x minus 1. So I will put limit here. So limit extends to infinity. This is what? 0. Limit extends to infinity. This is 0 because this is in the denominator. So all these terms will become 0 if I put the limit. So only one with this one will be there. So the answer will be, so option A will be the correct answer. Okay, let me change the color of the PDF. It's very brightening. Just a minute. Yeah, now it's all right. That was very bright. So your eyes will strain to look at that continuously. Okay. So question number 2. Yeah. The eigenvector E1 corresponding to the smallest eigenvalue of the matrix of the matrix What is the matrix? 2a squared a 0 a 1 a 0 a 2a squared. Okay, where a is equal to root over of 3 by 2 is by given by what? In terms of its transpose. In terms of its transpose. Okay. Eigenvector E1 corresponding to the smallest eigenvalue of the matrix. This one is given. Where A is equal to root over 3 by 2 is given by. The option A is E1 transpose is equal to 1 by 2 1 by root 2 minus 3 by root 2. Okay. Option B E1 transpose is equal to 1 by 2 root over 3 by 2. Okay, my bad. Just. Okay, this is a matrix now. My bad. I'm writing in terms of matrix, so it should be like minus. Okay, I got confused myself. So 1 by 2. This is a matrix. Okay, this is a row matrix because we are writing in terms of transpose of it. So 1, now root 3, and 4. So C E1 transpose is equal to 1 by root 2 of 1, 0, minus 1. Option B E1 transpose is equal to 1 by root 2 to 1, 0, 1. Okay, so these are the options. Question is eigenvector of E1 corresponding to the smallest eigenvalue of the matrix. So the smallest eigenvalue we have to calculate of this matrix and eigenvector corresponding to that eigenvalue. Okay, so yeah, where A is equal to root over 3 by 2, this is put it at the end. Don't worry. Or you can put it directly. No. Put it at the end. Otherwise, maybe you're confused because this will be root 3 by 2, root 3 by 2. Okay. So eigenvector we have to calculate. Let's do it. You can take your time. You can pause the video. Okay. So, mm, let me try. Okay. Let's first write the matrix. The matrix is what? The matrix is A is. Suppose the matrix is A. A is equal to 2a square A 0 A 1 A then 0a 2a square. This is the matrix. Okay. So the smallest eigenvalue. That means let's calculate the eigenvalue first. So eigenvalue equation we know a minus lambda is equal to 0. Right. So eigenvalue will be 2a square minus lambda a 0 a 1 minus lambda a 0 a 2a square minus lambda is equal to 0. So yeah, I think it would be better to put the values of root over 3 by 2 so that we can get a simplified version of it. So it will be 2 into 3 by that is 3 minus lambda. Okay, and this will be a root over 3 by 2 0. This is root over 3 by 2 1 minus lambda root over 3 by 2 0 root over 3 by 2 and this is again 3 minus lambda. Okay, is equal to 0. So let's expand it. So if I expand it, I will get 3 minus lambda whole into 1 minus lambda into 3 minus lambda minus 3 by 2. So there is 3 by 2 so plus root over 3 by 2 and this is 0. This is root over 3 by 2 whole into 3 minus lambda. Okay. Okay, this is minus. Okay. Okay, there should be a minus here. This is 1. Yeah. So last term is 0. Okay. This is 0. So let's simplify 3 minus lambda. 3 minus lambda minus 3 lambda plus 3 lambda. In TIFR, you don't have to do everything. Okay, the question will be tough. So take your proper time for the ones you are able to solve. 3 by 2 into 3, there is another 3. You know? Now root over 3 by 2 lambda minus minus plus. So let's okay, these two are cancelled. 3 minus 3 by 2 is how much? 3 by 2. So this becomes 3 by 2 minus lambda. Okay, this is 9 by 2 minus 9 by 2, and this is a plus 3 by 2 lambda is equal to 0. Okay, so multiply them now again. 9 by 2 minus 3 lambda minus 3 lambda by 2 plus lambda square minus 9 by 2 plus 3 by 2 lambda is equal to 0. See, these two are cancelled. These two are cancelled. So what is left? Lambda square minus 3 lambda is equal to 0. So lambda whole into lambda minus 3 is 0. So lambda is 0 and lambda is 3. Okay, these are the two eigenvalues. What is the question asking me? Eigenvector corresponding to the smallest eigenvalue. Okay, smallest eigenvalue is your what? 0, right? 0 is the smallest eigenvalue. So let's calculate the eigenvector corresponding to smallest eigenvector corresponding to smallest eigenvalue 0. I'm just writing for you sake. Smallest eigenvalue, that is 0. So how to calculate eigenvalue? We know Ax is equal to lambda x, where x is the eigenvector. So A is what? The matrix. X is your, suppose x1, x2. This is a 3 by 3 matrix. So x1, x2, x3 is equal to lambda is 0. x1, x2, x3. Correct? Yeah. So what was the matrix? What was the matrix? 2a square, a 0, 2a square, a 0, a 1, a 0, a 2a square. Isn't it? So a square is 3 by 2. So 3 root over of 3 by 2, 0, root over of 3 by 2, 1, root over of 3 by 2. Now 0, root over of 3 by 2. This is 2. Okay, sorry, 3. x1, x2, x3, and this side is completely 0. So we just have to equate them. So let's write the equations. 3x1 plus root over 3 by 2 x2 is equal to 0. Root over 3 by 2 x1 plus x2 plus root over 3 by 2 x3 is equal to 0. Then root over 3 by 2 x2 plus 3x3 is equal to 0. So from these equations we have to find x1, x2, x3, which will give us the eigenvector. Okay, 3x1 is equal to minus of root over 3. I have to express it in a single term. So I will, let me do it. Let me express everything in terms of x2. Okay. x1 is equal to what? Minus of 1 by root 6 x2. Because 3 comes here, 3 comes down. Okay. Now x3. X3 should be what? 3x3 is equal to minus root 3 by 2 x2. So it's the same. x3 is also minus 1 by root 6 x2. Yeah. So x1, x3 are same. x2 is x2. So the eigenvector is what? Eigenvector is minus 1 by root 6 x2. x2 is x2. And it's minus 1 by root 6 x2. Yeah. So if I multiply minus root 6, that will be, I will be getting, what are we getting? Is exactly what? 1 minus root 6, 1. Okay. And this is 1 by 6 plus 2. So root 8. That is 2 root 2. So 1 by 2 root 2, 1 minus root 6, 1. I think this should be the answer. And it is written in transpose form. So 1 by 2 root 2, 1 minus root 6, 1. Let's see, let's check the options. Okay. Can you see whether any option has it? Whether any option can be this one. See. Okay, yeah. See this one. I will check the first option. Okay, first option. See, E1 transpose is equal to 1 by 2, 1 by root 2. Never get worried that your answer didn't match the option. It will be in the option. Okay, you just have to think a bit more. See, if I multiply root 2 everywhere, okay, or if I yeah, if I multiply root 2 everywhere, or uh, suppose if I take the 1 by root 2 common outside, so 1 by 2, yeah, I cannot multiply, I'm sorry, my bad. 1 by root 2, I take 2 common from the matrix. Okay, so the outside becomes 1 by 2 root, right? And 1, okay, what will be this one? Minus root 3 into root 2, isn't it? Because I took 1 by minus root 6, this one. Isn't it the answer we got? See? Okay, yeah, that's it. Option A is the correct answer. Never get worried that your answer didn't match the options. It will be in the options, so just have to think a bit more. Yeah, very good. Yeah, the answer is correct. I check the answer, it's correct. So this is the way to do it. Okay. Yeah. Eigenvector questions are coming a lot, and they won't be easy. Like, it's easy, but bit lengthy. So you have to be patient. You have to get your basics right. Otherwise, you will like make mistake. Next question. Question number 3. Consider the improper differential. Consider the improper differential. What is the improper differential? ds is equal to 1 plus y square dx plus xy dy. Okay, an integrating factor, an integrating factor for this is what? What is the integrating factor here? A is minus x, b is 1 plus x square, c is xy, and d is minus 1 plus y square. Okay, let's try. Consider the improper differential ds is equal to 1 plus y square dx xy dy. An integrating factor for this is what? Try. I am giving you 2 minutes. Yeah, how to solve it? Improper differential. So we have to convert it into a proper differential first. How do we do it? Let's try this question. And in the form of the question, if you remember, there is this form mdx plus ndy is equal to 0, right? M and n. So let's check if del m by del x, sorry, del m by del y, del n by del x, whether they are equal or not. Del m by del y is how much? 2y. Del m by del x is x. Or, sorry, y. So they are not equal. If they were equal, we could have done something. Okay. Integrating factor terms. How to solve it? If they were equal, what could have been done? If it was like mdx plus ndy is equal to 0, and if del m by del y equals to del n by del x, then the integrating factor would have been what? Del m by del y. Sorry. Would have been something like. No. My bad. So. No. Here, yeah, it's correct actually. Sorry. Here, this one is del m by del y minus del n by del x is equal to what? 2y minus this is y. So this is a function of y. Yeah, I can remember it now. This is a function of y. So if it is a function of y, we used to do something like integrating factor, something like what? A to the power integration a to the power fy dy, right? Yeah, now it's correct. Or what? By n, by n. Um, wait. You also try. I am trying also. I haven't done this question or I don't have the solution. TIFR only gives the answer, they don't give you the solution. So we have to try it out. This is 2020 question. Mm, by del y by del x whole divided by n. Yeah, if this is a function of x, then let's check 2y minus y divided by xy. N is xy. So, so this is what? Minus y by x. Sorry, xy. So minus 1 by x. So minus 1 by x. So integrating factor will be e to the power f of x dx. That will be e to the power minus 1 by x dx. That is e to the power minus ln x, which is which is 1 by x. So integrating factor should be 1 by x. Is it? No, it's wrong. The answer is wrong because it's not in the option. And thank God it's not in the option. Otherwise, I would have just ticked it. So this, I think this formula is wrong. Then please tell me which formula to use here. Consider the improper difference here. If I'm doing any mistake, please let me know. Oh, 2y minus y is y, na? How is it minus y? It's 1 by x. Really sorry. So this becomes e to the ln x, which is your x. Yeah, x is your integrating factor. Yeah, x is your integrating factor. This is not an option. It's not minus. So we'll consider minus x. The x is not there, so I think it should be minus x only. Yeah, yeah. We can't do anything here because these are not matching with x. We cannot do this because y is there. So this is the only option we can go with. Okay. Yeah. Okay. Let's go to the next question. Question number 3. Now question number 4. The sum of the infinite series. The sum of the infinite series S is equal to 1 plus 3 by 5 plus 6 by 25 plus 10 by 125 plus 15 by 625. Okay. So what is the value? Is given by is given by A. Option A. S is equal to 125 by 64. B is S is equal to 25 by 16. Option C. S is equal to 25 by 24. Option D. S is equal to 16 by 25. Okay. The sum of the infinite series is what? Which try see whether this comes in any form of you know any form of the series we all know, and that only we can do it. We cannot just keep adding them or something. We have to get a pattern. In this type of sum of infinite series, we have to get a pattern, otherwise we won't be able to solve it. We have to get a pattern, we have to like take summation or something else. Some of the infinite series come this type of questions come in TIFR. That's the thing. This question this type of question won't come in CSR net or gate. This type of question will come in TIFR and JST. This is their pattern. Okay, please remember this. These are very different exams from gate and net. Sum of the infinite series S is equal to 1 plus 3 by 5, 6 by 25 plus 10 by 125 plus 15 by 625. How to solve it? Can we get a pattern here? Any pattern in this? Let me write it again. S is equal to 1 plus 3 by 5, 6 by 25 plus 10 by 125 plus 15 by 625. So is there any pattern here? This is 1. This is 3 by 5. If we go to the next term is multiplied by 5 in the denominator, 5 in the denominator, 5 in the denominator. This is, we can say 2n plus 1 if n is 1. This is, no, this is not 2n plus 1. No, 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 no. What's the difference between the 2 by 5 difference here? 15, 15 by 25, 9 by no, no. These terms are squared, but what about the terms in the numerator? I'm unable to. 3 into 2 is 6, 6. We have to get a pattern. This is very important in this type of some questions. So I can somehow like this is 10, no? This 10 by 125 is 15 by 625. So if this term is like 5 by 25 and this term is like what? It's like 1 by 5, something like that. Something in this kind of frequency. Okay, so we can get something from it. Okay, okay, yeah. Yeah, 5 by 125 we can get from here. This is 6 by 25. Now I can do like 5 plus 1 by 25, isn't it? Yeah, let's see. Let's check. So, S is equal to 1 plus 3 by 5 plus 5 plus 1 by 25. Okay, by 10 by 25 plus 15 by 625 and it goes on. So 1 plus 3 by 5 plus I will kind of separate them 1 by 25 plus 5 by 25. The thing I wanted 1 by 10 by 125, 15 by 625 and it goes on. So this is kind of I wanted. I want another term also that is 1 by 5. So let's do one thing. Um, I will add 125, 1 by 25, I will subtract 1 by 5. So 1 by 5, I will subtract 1 by 5. If I do that, will I get anything? Oh, okay. Um, oh, sorry. This term is actually 1 by 5, isn't it? It's actually 1 by. Okay, let's do one thing. Let's take 5 common. If I take 5 common, will that help me in anything? Um, okay, let's do. Let's divide 5 everywhere. It's 5. This is 1 by 5. This is 2 by 25. 3 by 120. Okay, let's write it again. 1 plus 3 by 5. It's 1 by 25 plus 1 by 5 plus 2 by 25 plus 2 by 25. This cannot be divided anymore. Dot dot dot. Okay. Yeah. Mm, so what can I do from here? I can do one more thing. By 3 by 5 plus. I'm getting a pattern. I'm getting a pattern slowly. 1 by 5 to the power 1 plus 2 by 5 to the power 2 is 3 by 5 to the power 3. Dot, dot, dot. Can I do something from here? Do you know what is this called? This thing. This kind of thing. There is another term for it. This is called orthogeometric progression. Okay. It's called what? Orthogeometric progression. Okay. Orthogeometric progression. Here what is S? S is equal to A by 1 minus M plus D into M difference into M divided by 1 minus M. Okay. So this is the formula for orthogeometric progression. So this is, see, you have to remember it. There is no other way. Okay. So how will you do it? Only if you do a lot of questions. So what is M here? M is common mean of GP. Common multiple. Common. So my bad. So how much multiple? And D is your common difference in AP. It's a mixture of AP and GP, okay? Arithmetic progression and geometric progression. So that is called arithmetic progression. Common. Yeah. So, okay. So what can we do here? With this, let's add another method. This is 0 by 5 to the power 0. Okay. This 1 by 5 to the power 1 plus 2 by 5 to the power 2. Like that. Mm, so, uh, can we do here? See, the arithmetic progression is this one, where like the progression is starting from here, ending from here, so we can simply add them. There's no problem with it. The main problem is this one. This is the progression that is up to infinite. Okay. This one we can add it, so we don't need to do anything with it. So this is the one where we need to do the that thing. So let's do one thing. S is equal to, simply we'll add them. See, 1 by 3, 1 plus 3 by 5, that is 8 by 5 plus 1 by 25. If I do it, it's 25. This becomes 32. Sorry, 40. So 41 by 25. Simple. 41 by 25 plus. This is the one. Okay. What is the first term here? 0 by 5 to the 0 plus 1 by 5. So 0 is the first term. Okay. A is the first term. It's starting on A only. Okay. We cannot directly go to 1 by 5. A is 0. So this term becomes 0. So what is left? So D into M. So what is D? What is D? This is a mixture, as I said, this is a mixture of orthogeometric progression. Okay. No, no, sorry. My bad that I told this one is arithmetic. This is the arithmetic and geometric progression. See, how will you know this is arithmetic geometric progression? This is simple. See, 0 to 5 to the power 0, 2 to the power 5 square, 5 cube. It will go on like this. So see, the upper parts are increasing by 1, 1, 1, 1. This is arithmetic progression, AP. And the lower parts are increasing by multiple of 5, common multiple, 1 by 5. 1 by 5, another square. So 1 by 5, 1 by 5. So this is your common multiple M. This is your common difference D. So this is arithmetic progression. The lower part is geometric progression. So at a mix, it's called arithmetic progression. Did you get it? Yeah. This is as a mixture called orthogeometric progression. So what is the formula for it? Again, I will write it. This is called A by 1 minus M plus um, D into M divided by 1 minus M whole square. So D is your what? Your common difference is 1 in arithmetic progression. Common multiple is 1 by 5 in geometric progression. First term is 0. 0 by 5 to the power 0. 5 to the power 0 is 1, 0. So this is D is 1 into 1 by 5. 1 by 1 minus 1 by 5 whole square, that is 1 by 5 divided by 4 by 5 whole square, that is 16 by 25. Okay, 5, 5, 5 by 16. This is on. So this is the S for the orthogeometric, and this is also remaining 41 by 25 plus 5 by 16. 41 by 45, 25 was the summation for this one. Okay, so the whole summation is S is equal to 41 by 25 plus 5 by 16. So this is your 25 into 16 is how much? I think something to 40 something like that. 50. 400. 16 into 41. 625, 25. 656 plus this is 125. Okay, so it's kind of 781 by 400. So this is the answer. Okay, you can do a bit more of this. 781 by 400. Simply multiply by divide by 4. 4, 4, 1 and 4. 3, 8. 4 nines are 36. 4 fives are 20. So, okay, I cannot just leave it here. 4 twos are 8. 2, okay, 190. Sorry, 1.9525. I gave the dot here because of 400. Okay, don't. This is my way of calculating. You can calculate on your own way. Don't see my calculation. I did it for myself. Okay, so 1.9525 or something like that you will get. Okay, yeah, this is the answer. Was it in the options? What what are the options? I forgot. What we got? What did you get? 781 by 400. Okay, you have to simplify it, or you can do one thing. You can check the 1.9 thing everywhere. This won't be 1.9. I don't think this will be 1.9. This might be 1.9. Okay, so option A may be, yeah, option A would be the correct answer because I don't think this will be a 1.9. 90, no? 16 5 side, no, this is not. 64. Oh, this. Oh, sorry. 61 0. Yeah, this one is the correct answer. 125. See, what a good question it was. So this question you knew a lot. Okay. Yeah. Question number 4 is done. Next question. Question number 5. Question number. The solution of the differential equation. The solution of the differential equation dy by dx is equal to 1 plus 1 by y by x minus y square by x square for x greater than 0 with boundary condition boundary condition y is equal to 0 at x is equal to 1 is given by y of x is equal to what? The options are x1 to x square minus 1 by x square plus 1. Option B, x1 to x minus 1 by x plus 1. Option C, x minus 1 by x plus 1. Option D, square minus 1 by x square plus 1. Right? The solution of the differential equation you have to find. This is the differential equation boundary condition y is equal to 0 at x is equal to 1 is given by y of x is how much? Try this question. Then how can we solve it? See, this is a if you see properly, this is a homogeneous differential equation. Y by x, powers are same, right? So what do we do at homogeneous differential equation? We simply put y is equal to what? Vx, right? So dy by dx is equal to v plus x or dv by dx, correct? So in place of dy by dx, I will simply put v plus x dv by dx is equal to 1 plus y by x, that means vx by x plus y square, vx square by x square. So x x square gone. So now v also gone. So x dv by dx is equal to 1 plus v square. So dv by 1 plus v square is equal to dx by x. Okay, simply integrate both sides. So this is tan inverse v is equal to ln x plus c. Now v is what? So v is simply okay, y is equal to vx, v is y by x. So tan inverse y by x is equal to ln x plus c. Correct? Now we'll just simply put the boundary conditions. Y is equal to 0 as x is equal to 1. So when y is equal to 0, x is equal to 1, put it here. So tan inverse 0 directly is equal to x is equal to 1. ln 1 plus c. So ln 1 is 0. Tan inverse 0 is 0. So c is equal to 0. So tan inverse y by x is equal to ln x 0. So we are asked what? Y of x. Okay, so y in terms of x. So this becomes y by x is equal to tan of ln x. Okay, and y is equal to what? X tan ln x. But I don't think this is in the options. Yeah, this is not an option. Have I done a mistake? Okay. Okay. Wait. Oh, my bad. This is a minus sign. There is a minus sign here. I have put plus here. It's a terrible mistake. So this whole solution is wrong now. Let's do it again. Whole solution gone wrong. Okay, anyway. Y is equal to Vx V plus x dv by dx. So V plus x dv by dx is equal to 1 plus Vx by x plus, sorry, 1 plus Vx x. No, what? Sorry, 1 plus V minus again V square. Okay, V cancelled. So x or dv by v square is equal to minus dx. Sorry, why I'm rushing? That's why I'm making see. I'm rushing. That's why I'm making mistake. I should be doing it slowly. So dv by 1 minus v square is equal to dx by x. Integration. What is the integration for this one? Do you remember? If you remember, just tell me. Do you remember this integration? Hmm? This is a straight integration. ln half ln what? 1 plus v by 1 minus v. Okay. Please remember this integration. So don't have to do it like expand it. It's already a long question. If you expand it more, it will take so much time. Let's see. Now v is what? Y by x 1 by 2 ln 1 plus y by x by 1 minus y by x is equal to ln x plus c. So y is equal to what? Y is equal to 0, x is equal to 1. When y is equal to 0, x is equal to 1. So let's put it here. So half ln y is equal to 0. So 0. Oh, we don't know. We didn't put it. This is equal to 1. So this is 0. This term is 0. Right? ln 1. C is 0 eventually. So ln half ln 1 plus y by x divided by 1 minus y by x is equal to ln x. We need to target in terms of y. So let's take half to the side. Ln 1 plus y by x 1 minus y by x is equal to 2 ln x can be written as ln x square. Okay. It's giving some steps here. So we can go take to the other side and it will be completely cancelled out. So 1 plus y by x by 1 minus y by x is equal to x square only. Okay, take the LCM. X plus y by x minus y by x cancelled out x square. So x plus y is equal to x cube minus y x square. Okay, take the x to the side. Y plus y x square is equal to x cube minus x. Okay, these are the basic things I don't want to explain. 1 plus x square is equal to x square into x minus 1. So y is equal to x square into x minus 1 divided by 1 plus x square. That's it. That will be the answer. Okay, that would be your option. Option A. Yeah. My bad again. Only x can be taken as. Yeah. Alright. Okay. Again, a good question. No, it's a standard question. I just made the mistake of the minus. Otherwise, it could have been solved a long time ago. Okay. Next question. Question number 6. Question number 6 is the value of the integral integration 0 to infinity dx by x fourth plus 4 is always some this type of question will come in JST or TIFR surely. Okay, so you have to recognize what chapter it is. Don't go to this is complex integration or complex analysis chapter. Okay, sorry, I said not integration. Complex analysis chapter. So we have to think according to that. All right. So how to start this question? What do we do exactly in complex integration? So we have to, when this type of question is given, we have to consider the minus infinity to infinity, okay? And just like divide 1 by 2. So this integration can be written as min, sorry, 1 by 2 minus infinity to infinity dx by x 4 plus 4. I can write it as in complex chapter we usually write from z. Okay? So dz by z4 plus 4. So this is f of z is what now? 1 by z4 plus 4, right? So this is the function. Okay. Okay. Now how to get poles? Poles we can get if we equate the denominator to 0. Okay. So how do I do it? Z square. No, how do I do it? Z fourth is equal to minus 4. Okay. Is there any way to solve it? See, minus 1 is usually written in this chapter as e to the power pi, I pi. Yeah, e to the power I pi, because e to the power I pi is what? Cos pi plus I sin pi. So cos pi is minus 1. So you can write z to the power 4 is equal to 4 e to the power I pi. Alright? Yeah. So now z can be written as 4 to the power 1 by 4 into e to the power I pi by 4. Got it? Yeah. Yeah. Otherwise, just okay, my bad. We have to write it in general terms. Okay, we have to write 2n plus 1 I pi. Right. So just write it like that. Because this is an odd number. Odd number in general we have to write 2n plus 1. 2n plus 1 I pi. 2n plus 1 I pi by 4. Okay. Or I 2n plus 1 pi by 4, no problem. Where n starts from 0. 0, 1, 2, okay. So now, how to solve it? So let's take the value of 0 only here. So eventually it comes to that. Z is equal to 4 to the 1 by 4. E to the power I pi by 4. So if you remember the expansion of this one, I can cos theta plus I sin theta. So Z is equal to 4 to the power 1 by 4 cos pi by 4 plus I sin pi by 4. So cos pi by 4 is 1 by root 2. So 4 to the power 1 by 4. 1 by root 2 plus I 1 by root 2. Okay. So 1 by root 2, let's take it out. 4 to the power 1 by 4 divided by root 2. 1 plus I. Okay. So what can we do from here now? Okay, 4 to the power 1 by 4. Can I write like this? 4 to the power 1 by 2 whole to the power 1 by 2 divided by root 2. 1 plus I. 4 to the power 1 by 2 can be written as 2. So this becomes eventually 2 to the power 1 by that is root 2. Yeah. So root 2 by root 2. See? Becomes so simple now. 1 plus I. This is the final expression. 1 plus I. Okay. So what can we do now? What can we do now? So this is when n is equal to 0. When n is equal to 0, these are the values. Like this is with z1, I will write it as z1. Okay. 1 plus I. Now suppose n is 1. N is 1. So this will become what? Z2 will become 4 to the power 1 by 4 e to the power I 3 pi by 4. Right? N is 1. 4 to the power 1 by 4. So cos 3 pi by 4 is I sin 3 pi by 4. 3 pi by 4 sin 3 pi by 4 is minus cos, sorry, plus uh, cos is negative. So 4 to the power 1 by 4 is minus 1 by root 2 plus I sin 1 by root. Sorry, I 1 by root. So 1 by root 2 goes out. So again this becomes minus 1 plus I. Okay, exactly like that. If you can just guess a bit, n is equal to 2 will be what? This is z2. Z3 will be what? Minus minus, and z4 will be what? Plus minus. Okay, you can guess it from here. You can just guess it. Yeah. So uh, see, yeah. Another thing is here the limit is given as 0 to infinity or minus infinity to infinity. So minus infinity to infinity when it's given, so we will just calculate the upper half of it. Okay, we'll just calculate the upper half of it because see 0 to minus infinity to infinity. So this is like this. So the upper half we will consider, and in the upper half, this z1 and z2 are only existing in the upper half. Plus 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 minus plus. So these two are in the lower half, z3 and z4. Okay, so we'll only consider these two. These two won't contribute. So we have to calculate the residue corresponding to what? Z1 and Z2. Got it? It's a very good question. This type of questions only come. They won't ask you the simple complex analysis question. Okay. So let's say I calculate the residue for it. I hope you can do it now. It's almost done. So d by dz, okay, 1 by z4 plus 4, and at what? Limit z is equal to z1, okay. So I can take a uh, derivative and all, and it will be 1 by 4zq actually. No, no, sorry. In the denominator only. Yeah, because if you remember that phi z by psi z, suppose. So to get the residue, like we can do like phi z by take the derivative of the lower part denominator and just put z is equal to zi or whatever. Okay, so take the denominator derivative. Put zq, z is equal to z1. Okay, so z1 was what? Z1 was what was Z1? Whatever there was, just put it. Okay, whatever we got value we got in the previous part. And Z2 also same thing, and Z is equal to Z2. Okay, I hope you can do it now. I have almost done the entire thing. Yeah, please take your time and please finish this one. Okay, done. So yeah, that'll be it for this class. Okay, and we'll be solving more questions. We have been solving a lot of questions. You can check the playlist of TIFR, quantum mechanics, and statistical mechanics. Only one video I've done. This is the first video of mathematical physics, so I'll be solving everything. all the chapters. Like I cannot just focus on quantum only. So we're doing mixture wise. So you continue preparation, and whenever you feel like, you can watch my videos to try some questions. Okay, there are a lot of videos. You can go to the playlist of especially quantum mechanics and statistical mechanics. I've done a lot of videos, so you can go there and solve those questions. I'll be trying to do more advanced questions from here on. Okay. These were really good advanced questions. So I hope you got it. It needs a bit of creativity actually to solve this kind of question. And yeah, I'll be solving more questions, and I hope you do. And yeah, if you have any doubts, you can ask me in the comment section, or you can directly mail me. Okay, I had given the mail in the previous video, but anyway, I will give you the mail. Mail is alexbisek@hotmail.com. Okay, you can send me email here, so that we can contact, like we can clear your doubts or any queries we have. Okay, yeah, all right, all right. Thank you very much, and yeah.